Vectors. A vector is a set of direct line segments with the same direction and magnitudes or lengths. The move from A to B is written as vector AB, which is equal to vector OB minus vector OA, or the vector XY. For example, vector 1, 2 means one step in the eastern direction and 2 steps in the northern direction. But if it was -1 and -2, it means one step in the western direction and 2 steps in the southern direction. Vectors can also be represented thus. Vector A. The length of a directed line segment represents the magnitude of the vector. The magnitude of a vector A is written as the modulus of A, which is equal to the square root of, open your bracket, x2 minus x1, close your bracket, squared, plus, open your bracket, y2 minus y1, close your bracket, squared. For a vector A and a scalar number k, Ka is a scalar multiple of A. Ka will be parallel to A. Vectors are collinear when they are parallel to one another and have a common vector or a common factor. We look at some examples. 2016. In the diagram below, OAB is a triangle in which vector OA equal to 3A and vector OB equal to 6B, OC to CA equal to 2 to 3, and AD to DB equal to 1 to 2. OD meets CB at E, like that. Express each of the following in terms of A and or B, vector AB, vector OD, vector BC. Given that vector BE equal to H vector BC, express vector BE in terms of H, A, and B. We look at our solutions. So the first question is saying, find vector AB. Now, vector AB is the same as the movement from point A to O, and then the movement from O to B. If OA is a positive 3A, it means AO is a negative 3A. So our vector AB will be equal to vector OB minus OA. Where there's OB, we'll replace a 6B, and where there's OA, we'll replace a 3A. It's going to look like that. Vector AB is equal to 6B minus 3A. OD is equal to the movement from OA to AD. Now, the question is saying AD to DB is equal to 1 to 2. So what you're supposed to do is to add 1 plus 2, which is going to give us a 3. Meaning AD is 1/3 of AB. So we are going to replace, where there's OA, we'll replace our 3A. Where there's AD, we'll replace our 1/3 vector AB. Where there's this vector AB, we'll replace our 6B minus 3A. It will look like that. From here, we are going to expand. We'll multiply 1/3 times 6B, which will give us a 2B. 1/3 times negative 3A will give us a negative A. It will look like that. From there, we'll group the like terms together. 3A and negative A can be simplified. So 3A minus 1A is going to give us a 2A. Therefore, vector OD is equal to 2A plus 2B. Find vector BC. Vector BC is equal to OC minus OB. The question is saying OC to CA is equal to 2 to 3. So what we are supposed to do is to add 2 plus 3, which is going to give us a 5. Therefore, OC is 2 over 5 of the vector OA. So we are going to say BC, vector BC equal to vector OC minus OB, and then we are going to replace a 2 over 5 vector OA minus vector OB, which is 6B. Where there's OA, we are going to replace our 3A. So if you multiply 2 over 5 times 3A, you are going to get 6A over 5. It's going to look like that. So we have 6 over 5A minus 6B. Then we can always factorize the 6, which is going to give us 6, open your bracket, 1 over 5A minus B. Vector BE equal to H vector BC. Where there's BC, we are going to replace 6 over 5A minus 6B. It's going to look like that. Then we'll factorize our 6. Our vector BE will be 6, open your bracket, 1 over 5A minus B, close your bracket, H. 2017. In the diagram below, vector OP equal to 2P and vector OQ equal to 4Q and PX to XQ equal to 1 to 2. The diagram has been given, that is a quadrilateral. Expressed in terms of P and OQ, vector PQ, vector PX, vector OX. Given that vector OC equal to H vector OX, show that vector CQ equal to 4, open your bracket, 1 minus H over 3, close your bracket, Q, minus 4H over 3P. So we'll take it step by step. Find vector PQ. Vector PQ is the movement from P to O plus the movement from O to Q. Now, if the movement from O to P is a positive 2P, it means the movement from P to O will be a negative. So where there's OQ, we'll replace our 4Q, and where there's OP, we'll replace our negative 2P. It will look like that. So vector PQ is equal to 4Q minus 2P. Now the question is saying, given that PX to XQ equal to 1 to 2, what we are supposed to do is to add 1 plus 2, which is going to give us a 3. Therefore, PX is 1/3 of the vector PQ. So we are going to say vector PX equal to 1 over 3 vector PQ. Where there's vector PQ, we'll replace a 4Q minus 2P like that. So vector PX is equal to 1 over 3, open your bracket, 4Q minus 2P, close your bracket. Find vector OX. Vector OX is the movement from O to P and then the movement from P to X. So where there's OP, we'll replace our 2P, and where there's PX, we'll replace our 1 over 3, 4Q minus 2P. It's going to look like that. From there, we are going to expand. 1 over 3 times 4Q will give us a 4 over 3Q. 1 over 3 times negative 2P will give us a 2P over 3. So it's going to look like that. And then from here, we can group the like terms together. 2P and negative 2 over 3P can be simplified. So we'll say 2 is the same as 2 over 1. We'll find our common denominator, which is a 3. 1 into 3 is 3. 3 times 2 is giving us a 6P. 3 into 3 is a 1. 1 times negative 2 will give us a negative 2. 6P minus 2P will give us a positive 4P. So our vector OX will be equal to 4 over 3Q plus 4 over 3P, or 4 over 3P plus 4 over 3Q. Find vector OC, given that vector OC is equal to H vector OX. So what we are going to do is to replace 4 over 3Q plus 4 over 3P where there's vector OX. It's going to look like that. Factorize 4 over 3. When you factorize 4 over 3, you are going to have 4 over 3, open your bracket, Q plus P, close your bracket. We have that H, which has to be factorized. Then the question is saying find vector CQ. Vector CQ is equal to vector OQ minus vector OC. So where there's vector OQ, we are going to replace our 4Q. Where there's vector OC, we'll replace our 4 over 3Q plus 4 over 3P with our H. Then from here, we are going to group the like terms together. Our like terms are 4 over 1, which is a common fraction, 4 over 1Q minus, if you multiply negative 1 times 4 over 3Q, you get a negative 4 over 3Q H with that H. If you multiply negative 1 times positive 4 over 3P, you are going to get a negative 4 over 3P multiplied by H. From here, we are going to factorize our 4. When you factorize 4, you remain with a 1. When you factorize 4, you have a 1 over 3, which is the same as H over 3. And then we have a common factor, Q, minus 4 over 3 HP. So vector CQ is the same as 4. Open your bracket, 1 minus H over 3, close your bracket, Q, minus 4 over 3 HP. Hence shown. We go to 2018. 2018 is saying in the quadrilateral ABCD below, vector AB equal to A, vector AD equal to B, vector BC equal to 2B, and AE to AC equal to 1 to 3. Find in terms of A and OB, vector AE, vector BE, vector BD, hence or otherwise show that the points BE and D are collinear. So take it step by step. We are going to say AE equal to 1 over 3 AC. The question is saying AE to AC is equal to 1 to 3. Vector BE equal to a negative vector AB, because we are moving from B to A. If AB is positive, it means BA is negative, plus vector AE. Now the question is saying AE to AC equal to 1 to 3. So vector AE is 1 over 3 of AC. So we are going to replace. Where there's AB, we replace our A. So we are going to say this is the same as negative vector AB, which is giving us a negative A. Where there's AE, vector AE, we replace 1 over 3. Open your bracket, A plus 2B. Then from here we expand. We'll multiply 1 over 3 times A, which will give us 1 over 3A. 1 over 3 times 2B will give us a 2B over 3. Like that. Then we'll group the like terms together. Here, our common denominator is a 3. So we are going to say 1 into 3 is a 3. 3 times negative A will give us a negative 3A. 3 into 3 is a 1. 1 times 1A will give us an A. Negative 3A plus A is the same as negative 2A, which is going to look like that. Then we'll rewrite it by factorizing our 2 over 3. Open your bracket, we'll put our B minus our A, like that. Find vector BD. Vector BD is equal to vector BA plus AD. Now where there's this BA, we are going to put a negative A because we are moving from B to A. A to B is a positive A, but when you move in the opposite direction, you have to put a negative. So we are going to say vector BD is equal to vector BA plus vector AD. We'll replace them like that. And then we can rewrite it by saying vector BD is equal to B minus A. Vector BE equal to 2 over 3. Open your bracket, B minus A, close your bracket. And vector BD is the same as open your bracket, B minus A. Now you find that they have a common vector or a common factor, B minus A. And then the vector BE has a scalar K, therefore they are collinear. They have a common vector, B minus A. (2019). In the diagram below, vector OA equal to A and vector OB equal to B and AC to CB equal to 1 over 2. Express in terms of A and OB, vector AB, vector AC, vector OC. Given that M is the midpoint of OC, meaning M cuts OC into 2 equal parts, show that vector AM equal to 1 over 6, open your bracket, B minus 4A. So take it step by step. Vector AB is equal to vector OB minus OA. Vector AB is equal to vector OB minus vector OA. Then we'll substitute. Where there's OB, we'll replace our B, and where there's OA, we'll replace our A. So therefore, vector AB is equal to B minus A. Find vector AC. Vector AC is 1 over 3 of vector AB. The question is saying AC to CB is 1 to 2. So what we are supposed to do is to add 1 plus 2, which is going to give us a 3. So vector AC is 1/3 of vector AB. Where there's AB, we'll replace our B minus A. So we are going to say vector AC is equal to 1 over 3, open your bracket, B minus A. Vector OC equal to vector OA plus vector AC. Where there's OA, we'll replace our A. Where there's vector AC, we'll replace our 1 over 3, open your bracket, B minus A, close your bracket. And then we are going to expand. 1 over 3 times B will give us a 1 over 3B. 1 over 3 times negative A will give us a negative 1 over 3A. Like that. Then we'll group the like terms together. A and negative 1 over 3A can be simplified. We'll group them like that. Common denominator is a 3. So we are going to say 1 into 3 is 3. 3 times positive A will give us a 3A. 3 into 3 is a 1. 1 times negative 1A will give us a negative 1A. So if you simplify 3A minus 1A, you get a 2A. Therefore, vector OC is equal to 1 over 3B plus 2 over 3A. Part 2. Find the vector AM. Vector AM is the same as vector AO plus half vector OC, because M is the midpoint, meaning it's cutting the line OC into 2 equal parts. Where there's AO, we'll replace our negative A. If OA is a positive A, it means AO is a negative A. And then we are going to say half. Where there's vector OC, we'll replace our 1 over 3B plus 2 over 3A like that. Then we'll expand. Half times 1 over 3 will give us 1 over 6. Half times 2 over 3 will give us a 2 over 6. So we are going to say 1 over 2 times 1 over 3B will give us a 1B over 6. 1 over 2 times 2A over 3 will give us a 2A over 6. It will look like that. Then we'll group the like terms together. Negative A and positive 2 over 6A can be simplified. So from there, we are going to say common denominator 6. 1 into 6 is a 6. 6 times negative a will give us a negative 6a. 6 into 6 is a 1. 1 times 2a will give us a 2a. Negative 6a plus 2a is the same as a negative 4a, like that. Factorize the 1 over 6. We are going to get 1 over 6, open your brackets, b minus 4a, close your bracket. Therefore, vector am is equal to 1 over 6, open your bracket, b minus 4a, close your brackets, hence shown. As simple as that.